All right, guys. So the next section here is 4-4 graphing a function rule. So as you can see in your textbook, really all we're going to do is be graphing some sort of different equations. How do we do that? We create a table of values. So we're going to plug a value in for our independent variable, which is x. So just take any number you want, plug it in for x, do the math, get your output y, create a table of values, plot them, and you have it graphed. But we're going to be talking about a couple of different types of functions. We'll be talking about linear functions, we'll be talking about absolute value functions, and like quadratic functions, all right? But in each case, really, all you need to do is create your table of values. And once you create your table of values, just plot the points on a coordinate plane, and bam, you're done. So if we're looking at this first one here, y equals negative 2x plus 1. So I'll just draw my coordinate plane. And what I'll do is, here's my x, and here's my y. I'll just take some values and plug them in. Okay, let's say, what can I plug in for x? Well, since I'm graphing it, I really don't want to pick points that are too far away from the origin. So how about like we pick negative 2, 0 is always a good number to plug in, and 2. If I plug in negative 2, I'll get negative 2 times negative 2, which is 4. 4 plus 1, it will get me 5. If I plug in 0, I'll get negative 2 times 0, which is 0 plus 1, which is 1. And if I plug in positive 2, I'll get negative 4 plus 1, which is negative 3. Now with a linear equation, when I plot these, I should get a straight line. So negative 2, 5, negative 2, 1, 2, 3, 4, 5 would be right here. 0, 1 is located right there. And then 2, negative 1, 2, 3 is located right there. And you can see this pattern looks like it remains consistent here. I go down 1, 2, 3, 4 over 2, 1, 2, 3, 4 over 2. So that's enough. Now I just connect my dots there, and I've graphed that linear equation. Okay? How many points do you need? You can take as many as you want, but really 2 is the minimum. But you don't want to stop at 2, because if you make a mistake, you don't know you made a mistake. So you want to have at least 3 points. Okay, with linear equations. Now, the other types of equations that we're talking about here would be non-linear functions. So we talked about what non-linear functions are. Stuff that's going to look like this here, which is an absolute value, or something like this here, which is a quadratic function. We're going to do the same thing. So let's say we were given the y equals the absolute value of x minus 4 function. So y equals the absolute value of x minus 4. We're going to do the same thing. We're going to create a table of values, but the issue now is, since it's absolute value, I know it's going to look sort of like a V. So what I need to do is put enough points on here so I can possibly find where that turns. So that's really just through guessing and checking. So if I put in like negative 3, negative 2, negative 1, 0, 1, 2, I want to have enough points here so that I can try to find that where it turns around. So when I plug in negative 3 here, I'll get 3 minus 4, which is negative 1. Negative 2 is 2 minus 4, which is negative 2. Negative 1 is 1 minus 4, which is negative 3. 0 would be negative 4. Positive 1 is negative 3. And I can start to see I have some things repeating here. So if I plug in 2, I'm going to get 2 minus 4, which is negative 2. So now I go ahead and plot my graph. Whoops. Notice that when I draw my coordinate plane, if I do that neatly, okay, you want to be on, using the graph paper, you want to be on the blue lines. So negative 3, negative 1, negative 1, 2, 3, negative 1 will be down here. Negative 2, negative 2, negative 1, negative 3. You can start to see it almost looks linear, but 0, negative 4. And then it starts to pop up again, 1, negative 3, 2, negative 2. And that's what's going to happen each time you do an absolute value function. It's going to look like a V. So we just plugged enough points in, okay? Plot those points, and bam, that's what we have. All right, and then the last type of function here that we're talking about is if we look at some of the problems with the textbook. You see when the exponents get involved. So I know this guy's going to look like an absolute value. Something strange is going to happen here. Anytime the exponent is bigger than 1, it's non-linear, so something strange is going to happen. And what you need to do there is just put a bunch of points in there and create table of values, and plot those points. So let's say we were given something like y equals x squared plus 1. And all of these are different. The more we do these, you're going to recognize quadratics. You'll recognize what happens with cubics, stuff that we'll get later. But right now we're just sort of, whoops, I didn't mean to do that. I have to draw a table of values. So here's our x, here's our y. Just create a table of values here. Let's plug in numbers again. 0 is always a good number to plug in, but you want to plug in both positive and negative. Let's do -2, -1, 1 and 2. So if I plug in 0, I'll get 1. If I plug in -2, I get -2 times -2, which is 4 plus 1 is 5. -1 times -1 is 1 plus 1 is 2. 1 squared is 1 plus 1 is 2. 2 squared is 2 squared plus 5. And notice I start to get some repeats over here. Okay, that's a 5 there too. So now if I go to plot these points, 0, use a different color. 0, 1 is right there. -2, 1, 2, 3, 4, 5. -1, 1, 2. 1, 2, and 2, 5. So then it would be over 1, 2, 1, 2, 3, 4, 5 is right here. So now this one has a sort of a U shape to it. Okay, it's called a parabola. But again, we had to find that nice point where we bent. Okay, so now we have a non-linear function, and all we did was we just plotted a whole bunch of points, tried to see what was happening, plot those points, and then we were done. All right. So that's really all this is. This section, this chapter, this 4.4. The only other thing they mention are what's known as either continuous functions or discrete functions. Real easy. Continuous. A continuous function, when you graph it, okay, it's connected. All the points are connected. So you're going to see something where it's connected. Okay, there's not like a point, a point, a point, a point. It's just connected. Whereas discrete, well, there's a series of points that are not connected, but they can still be linear. So you might have a point, like something that would be like this, point, 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 but they actually aren't connected because it's only those values that are there. When you read some problems, you'll see why that happens. And there's one here on, okay, there's a picture in their textbook, continuous, discrete. For example, like real world problems like this, a farmer's market here, it says, a local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and price. Let's see, the amount of milk used to make the cheese and the price at which he sells the cream cheese are shown. Write a function for each situation. Graph each function. Is it continuous or discrete? So, like if you can't use parts of something, if you have to either use a whole gallon or not, that would be where maybe you have a discrete, okay, amount where you're not going to put it in like 2.2. You're only using a certain amount each time. Whereas, you know, if it's continuous, you'll be able to connect it all the way through. So again, here is an example of the weight of the cheese. Any amount of milk makes sense. So the correct, so connect the points. That's continuous. In a different problem, money earned. He can only sell whole wheels of cheese. He can't sell like parts of cheese. So therefore, he either sells 0 or 1 or 2. He's not going to come in. He's not going to slice one up. So that would be considered an example of a continuous. All right. All right. I'll leave an assignment for you guys to work on. But I hope this video was helpful. And I'll get back to you guys on Tuesday. All right. All right. Again, be kind to the sub today. We are heading to Cherry Hill West for our game. Game starts at 3 o'clock today, so by the time you guys get out of school, we'll be right in the middle of getting ready for that battle. All right, I'll see you guys. Take care.